Alright, here we go. We got question 6 here. We're going to probably go 6 through 10 depending on how long it takes here. Which expression is equivalent to 2x squared plus 7x plus 4? Okay, so there's multiple ways you can do this problem. I have some students where they'll take all your answer choices and multiply them together using this FOIL acronym. So we've seen that a couple times. I've had students in the past do factoring, which they try to go and figure out what foils into this answer. So they take that and factor it. And that's actually how I'm going to start this out. So the way I do this here, I kind of draw this little thing, just a visual representation of kind of what I'm doing here. This is the way I teach it. There's multiple ways. Different teachers teach this different ways. I might show you a different thing here. It's kind of the same idea here. But what I'm doing up here, I'm going to take my a times c values. I'm going to put it up here at the top of this thing. So that'll be 8. And then I'm going to put my b value down at the bottom, 7. And what I'm trying to figure out is what multiplies to 8 and adds to 7. So I'm looking for factors of 8, things that multiply to 8. Those factors have to add up to 7. All right, so when you try and do that here in this case, you kind of think for a while, okay, got to multiply to 8. So you could go like 1 and 8, 2 and 4. But that's really all you can do there. And 2 and 4, that's unfortunately, it's not going to even add up to 7. So in this case, this problem is not going to be factorable. So if it's not factorable, it's probably going to be none of these. So if you're not comfortable with factoring, you might need to go find some other videos on how to do some different factoring techniques. I know some people do it with this little box thing here and say, okay, you got 2x squared and then 4, and it's kind of the same thing. You figure out factors of 8 that got to add up to the 7x right here, and then you try to find those numbers and you put them in right there. But in this case here, once again, it's not factorable. You can't even do that right there. So none of those would work. Now, a different thought process here, if you want to do the foiling here, I'm going to take one of these answers, possible foil them here together. So you got 2x minus 1, then x plus 4. So if you try foiling that together, we could go and see if that matches our answer. And obviously none of them are, but I just wanted to show you one example of where we are doing the FOIL process. So 2x times x is 2x squared. 2x times 4 is 8x. Negative 1 times x is negative 1x. And then you got negative 1 times 4, that's negative 4 right there. So that'd be 2x squared plus 7x, looking really close, but then you get this negative 4 right here. All right, and that doesn't match exactly what I got. So that's probably, obviously it's not an answer right there. And you could go through and do that for each one of them to double check, but none of them are going to wind up working. That's because this trinomial right here is not even factorable. Okay. Moving along here, the graph is shown here on the grid. What it order pairs is solution set of 0.5x minus 2y greater than or equal to 3. So most of the times we do see this inequality sign, the greater than or equal to, and we know, okay, we got to do some type of shading. A lot of people, what they want to do is, if they see greater than, they usually want to shade up. Usually, most of the times that's true here, but we got something weird going on here. We got this weird rule that where if you divide or multiply by a negative number, it actually flips around your inequality sign. That's actually what's going to happen here. So like if I was going to graph this thing by hand, they already graphed something that is similar here. They graphed the same equation if it was equal. So now we're going to look here at the inequality. Let's get it into y equals mx plus b form so we could possibly sketch our own graph. So I'm going to subtract over the 0.5x. These are not like terms, so I can't technically add that to 3, so I just kind of write it off to the side here. So we'll say minus 0.5x and then plus 3. And then after that, you're going to take your value out there in front of y, and then you're going to divide. And what you got to remember here is when you divide by a negative, we're dividing by negative 2 right here, that's going to flip around your inequality sign. So it's actually a less than or equal to graph. And then you got 0.5 divided by 2, which that should be 1/4 there. The negatives, those will cancel each other out. And then I guess you got a y-intercept's kind of not a clean one, but I guess it's a y-intercept of negative 3/2, which is about 1.5. All right. So, yep, there's your negative 1.5. We're not really concerned about that because they already graphed it. The reason I solve for y is to figure out what's going on with the shading. The shading right here is going to be less than or equal to, so that means we need to shade down. Okay. So anything in this shaded region will be a solution. Now, there's also another criteria for solutions here. You got to think about this here. You also have these things. You have the dotted lines or the dashed lines, if you want to call it that, or solid lines. This line is a solid line, so that means also points on the actual line itself are solutions as well. Now, if this was a dotted line instead, points on the dotted lines are not solutions. So if you want to write that off to the side, it'd be a good note right there. Points on a dotted line are not solutions. Okay, sometimes you'll see some points on solid lines. So let's see all of our different ordered pairs. We'll go ahead and plot where they are. So you got -2 and then 0.5. So -2.5, that's up here in the third quadrant. I think that's going to be right there. So definitely not a solution. It's not even in the shaded region. 2, 1. So that'll be this point right here. That is definitely not a solution, not in our shaded region. You got 2, -1. And that point right there, that's exactly on our line right there. So that definitely looks like a solution. All right. And then you got -2 and then -0.5. So that'd be way over here. Definitely not a solution. So the best option, obviously, C. Now, with this one, honestly, even if you did mess up the shading, you wouldn't have probably gotten that one wrong because that 0.2, -1 is on that line. So it's not even really that good of a question there. They probably should have made it a little bit more interesting there. But anyways, there you go. So key thing, one more thing. Points on a dotted line are not solutions. So keep that in mind if that ever happens. All right, next one here. We got what value of x makes the equation, all of this stuff right here, equal to this right side right here. That is a fancy way of saying solve for x. Okay, there are multiple ways to do this type of problem here. Normally what I would do would be distribute, get x on one side, do any division at the end. But you could also take all of your answer choices, if you want, and plug them back in. Now, there's a problem here. You plug it in 1/3 into these fractions. That's gonna, or into the the parentheses for the x. It's not gonna clean up very well. So I'm gonna go ahead and solve for x. Maybe it'll kind of clean up nice and hopefully become a whole number here. So you got all this going on. In my previous video, if you're watching all of them here, we know if we got a negative outside the parentheses, it's kind of implied to be a -1 outside the parentheses, which we have to go back and distribute. So that'll be -5x, that'll be +7, that'll be +4x. And then there's your right-hand side. We'll clean that up here in a second by combining like terms. Same thing over here. We need to distribute the -2. That'll be -6x right there, and that'll be +8. Okay, now before I start thinking of moving things left or right or adding or subtracting from both sides of the equation, I'm going to combine my like terms right here. So you got -5x, you got 4x right there, so I think that's -1x. And then you got the +7. There's no other like terms with that on the left-hand side of your equation. All right, next thing, I'm going to move this 6x. I want to cancel that out, so we're going to go +6x and then +6x. So I'm going to go 5x + 7 equals 8. I'm going to subtract over 7 from both sides. So that's 5x equals 1. I'm going to divide by 5 at the end. That's x equals 1/5. By the way, so if you got 5 times x, the opposite of times divide. So that's why I did the division step. So J is our best answer. Once again, if you want to take those x values and plug them into your equation at the very beginning, you can do that. Now, when you go and plug in 1/5, that's going to get a little bit messy. 4 times 1/5. You're going to get some decimals there, so you got to be kind of careful on that. So that's why I solved instead of worked backwards on that one. Okay, number 9 here. What do we got here? The starting annual salary for an office worker at the company is $29,000. Well, that's not very good. All right, anyways, if the company awards an annual increase of 6.2%, which graph models the situation after the office worker receives an X annual increase? So what you're doing is over the years, you're going to repeatedly multiply by 6.2%. All right, so this is actually going to be one of these exponential graphs here. This is going to be exponential growth. Okay. This is your general format for exponential growth. You get y equals a times b raised to x. A is what you start with. That's what you're starting with. And then the b is what you're multiplying by every single year. So what we're essentially doing here is we're starting at 2,900, and then we're multiplying by 6.2, but actually we're getting that added on to what we already make. So actually it's kind of like you're adding 6.2%. It's like you're adding that on to the 100. So that's 106.2%. And when you are changing that to a decimal, we need to change that to 1.062. Okay, and then you're raising that there to x. All right. Now, actually, the equation doesn't help us a whole lot here. We just need to use logic as far as where the graph begins here. So we're starting at 2,900. So we're looking for graphs that start around there. A is a good one so far. C is not. C starts, it looks like, at 5,000. So we're definitely not starting there at that salary. D starts at 5,000. So we got two options here. We got one that's kind of steep and then one that's not as steep here. So you got to think about what you're increasing your salary by each year. You're only increasing it by 6%. So if you think, what's 6.2%? And I'm going to punch this out, 6.2. Oh, and I need to do 0.062 times the 2,900 that we're starting out with. After your first year, you're only getting 1,798 extra dollars. This option B here, it says after your first year you're making 4,500. I mean, you're basically going up by $1,500 there. That's a pretty big, or not $1,500, $15,000. That's a huge raise right there. Obviously, that can't be the option. So it's going to be option A. So once again, you want to use the idea of where you're starting from. You're starting at the 2,900, and then you're slowly going up over time. Okay. All right. Last one for this video, and then we'll cut it off here. Which expression is equivalent to this whole thing? So it's got a bunch of your exponent rules. Different teachers teach this different ways. The way I've always taught it, first thing I always do is if I see negative exponents, I got to flip that to the other side of the fraction here. That's because usually exponents, those are talking about repeated multiplication. So when you have negative exponents, we're talking about, like, it's kind of like the inverse. It's the opposite. So like c raised to negative 10 is like repeated division. So if that's repeated division, I need to flip that and put that down into the denominator. If you're already divided, and the opposite of dividing, that's like multiplying a bunch of times. So I'm going to put that up in the numerator. So essentially what I say, if you have negative exponents, put it on the other side of your fraction. So I'm going to keep all the same stuff here. I'm going to say a to the 4th, b to the 6th. Then I'm going to put my new a. I'm going to put that a to the positive 2. That's the a from the a to the negative 2. That's that moving up. Okay, you're bringing down the c to the 10th, so you're going to write that down at the bottom, but then you're bringing up the c to the 5th. So you kind of got all that going on. All right, I guess we still have b cubed down at the denominator, and then you're bringing down the c to the 10th. Okay, so now what you're going to do here, exponent laws tell you to subtract your powers of everything here. And the way I do this here, instead of thinking of, okay, like for example, you have the c's and that's 5 minus negative 10, and then thinking, oh, I have a negative exponent, what I do is I say, okay, is it top heavy or bottom heavy with your different variables here? So I look here, like for example the C's here, you're bottom heavy on the C's. So I'm going to subtract them. I'm going to say I'm bottom heavy, so I'm going to have 5 of them left over in the bottom or in the denominator. So also here with the A's, you're just straight up multiplying those. So you're going to add your powers instead of subtract. Look here at your B's. You got b to the 6, b cubed. You're top heavy, so you're going to subtract. But since you're top heavy, you're going to put b cubed up there in the numerator. All right, and then you also have the 14 over 8. Now your coefficients, you divide those like a normal fraction. I see that both of those are divisible by 2, so I'm going to say 7 up there, and the 14 divided by 2 is 7, and then 8 divided by 2 is obviously 4, and that is going to be my answer. And hopefully that matches up with something, and that looks like option H right there. Okay, that's it for this video here.